I have included for you the answers to the last homework assignment you completed, parts of a graph. For the first question, I gave you this equation. I asked you to find the line of symmetry, so I took the opposite of b divided by 2a and arrived at -3. Using -3 back into the original equation, I solved, got -1, so my vertex for this parabola is -3, -1. Because a is positive, I know it will be a smiley face or opening up. Finally, we have to find the roots, the x-intercepts. I just factored. When I find +2 and +4, remember that is not the roots. You need to then solve. So I'd set both of those equal to 0. So I end at -2, -4. The second question, I gave you a more complex equation with a equals 4, but I follow the same steps. Line of symmetry, opposite of b divided by 2a gets me -1 again. Using the line of symmetry, I put it back into the original equation, solve, and I got -9. So my vertex is at the point -1, -9. Because I have a as 4, I asked myself, can I make it simpler? Is there a number that goes into 4, 8, and 5? No. I needed to use my ACB chart. I need numbers that multiply to -20, but add to 8. That would be +10 and -2. So I wrote it like this. Remember, then we group, take out the greatest common factor, take out the greatest common factor. Here's where I would highlight because it's exciting. I have the same identical things. Group your greatest common factors together, your identicals, solve, set equal to 0, and I get 1/2 and -5/2. For the third problem I sent, again, line of symmetry, opposite of b divided by 2a, I got -5. Using -5 back in the original equation, I solved to get a vertex of -5, -4. Now I need to find the roots, the x-intercepts. So I need to find numbers that add to 10, multiply to 21, +3, +7, but I need to set those equal to 0 to get roots or x-intercepts of -3, -7. On this one, same procedure, opposite b divided by 2a to get my line of symmetry at 6. Substitute that back into the equation, solve, I ended with a vertex of 6, -4. Because a is 1, I need to find numbers that add to -12, multiply to +32, I get -4, -8. Those are not my roots. I then set each factor equal to 0, and I end with roots of 4 and 8. Again, repeating the process here, just a little bit bigger number, we end with a line of symmetry at -10. Substitute that in. I end at a vertex of -10, -25. To find my roots or solutions, I have to find numbers that add to 20, multiplying to 75, +15, +5, set each factor equal to 0, and I get -15, -5. Your challenge problem at the end, the reason I think it might be challenging is I didn't give you a C term, but remember you can add 0 to anything and it will never change. Line of symmetry, opposite of b divided by 2a, find the vertex. I got the vertex of 1, 1. Because it isn't a trinomial, I can't use the ACB chart. I need to distribute backward. There's two ways you can do it, and as you'll see, we get the same answer. You can factor out a -x, or you can factor out a +x. Both will get us roots of 0 and 2.